Hello all, welcome to the 64-bit edition of the SecurityTube Linux Assembly Expert course and certification. Now in this video, we will look at stack frames and how they are closely associated with procedures. So whenever a procedure is called, we need to create what is called a stack frame on the stack. Now the function of this stack frame is to act like a boundary wall and isolate all the data created by previous procedures. Typically the stack frame is created at the current position of RSP, and when the procedure is about to return, we need to go ahead and free the stack frame from the stack. So let me go ahead and give you a real world example just so that it's more clear. So I have main.c in which I have the main function that has a local variable and calls another function called proc. Proc again has a local variable and we print something in there. So now let me use GCC to compile this program, and then let me use GDB to load it up. Let's set the disassembly flavor to Intel, and then let me disassemble main. Now pay close attention to the first two statements. Now push RBP really pushes the base pointer on the stack. Typically this is what is the frame pointer, and then after that stores the current value of RSP inside the RBP register. Now at the very end we actually end up doing just the reverse using the leave instruction. Now I'll show you the alternate to leave in just a bit. Similarly, if you go ahead and look at the disassembly for proc, you would actually see the moment we enter the proc function, we do the same thing, and when we are just about to leave, we call leave and then ret. Now let me go ahead and open up procedure2.nasm. This is identical to procedure.nasm which we used in the previous video, with one key difference is that now we are trying to maintain the stack frame inside the procedure. So as soon as we are inside hello world proc, we push the value of RBP and move the value of RSP into RBP. After that we are free to use RSP as we please, and once we are at the very end we can call leave, which is really just doing the reverse, and again you can replace leave by these two statements which do exactly the reverse of what you did here, which is, if you kind of retrace it, we move RSP into RBP, and here in the first statement we move back the value we had stored up there back into RSP, and after that we pop the value of RBP back from the stack. So really what we are doing is we want to preserve RBP and RSP before we go ahead and do anything in that procedure, and when we are about to leave we again want to go ahead and retain the values to what they were originally before the procedure was called. This ensures that wherever we return to from this procedure will again have the same value of RBP and RSP in it just before it had called this procedure. So this is how stack frames are created and destroyed, and state is preserved on a per procedure basis on the stack. So let me go ahead and run this program. the output is totally identical. Let's go ahead and actually I forgot the TUI mode, should have been much more fun. Right. And as we step through the program, as soon as the procedure is called, we are in there. Now we push RBP on the stack. We copy RSP to RBP so that it remains preserved. Then we go through whatever we've been doing. And then finally, leave ends up doing just the opposite, right? Which is moving the value stored in RBP into RSP, and then finally popping the original value of RBP from the stack. So this ensures that when we are now back to the original procedure or original function, at this point RBP and RSP are exactly the same values as they were before, right? So this is a very simple program, but we've seen that even in the output generated, or rather the binary generated by much more complicated programs and compilers, the principle of maintaining and going ahead and storing the stack frame and then finally taking it off the stack when we go back from the procedure or function is pretty much the same. So this is a very important concept, and when you look at things like reverse engineering and all of that much later, you will find that this is a very important part of understanding what is really happening inside the program. So that's all I had in mind for this video. If you're enjoying your time at Pentester Academy, we would really appreciate if you could recommend us to your friends and colleagues in the InfoSec community. Thank you.